Welcome to algebra class, virtual algebra class. We're going to be reading some of this book called Life of Fred. Life of Fred, Beginning Algebra, as serious as it needs to be, by Stanley F. Smith, Ph.D. Chapter 1, Numbers and Sets. He stood in the middle of the largest garden he had ever seen. Chapter 1, Numbers and Sets. He stood in the middle of the largest rose garden he had ever seen. The sun was warm, and the smell of roses made his head spin a little. Roses of every kind surrounded him. On his left was a patch of red roses, Chrysler Imperial, a dark crimson. Grand Masterpiece, bright red. Mikado, cherry red. On his left were yellow roses, Gold Medal, golden yellow. Lemon Spice, soft yellow. Yellow roses were his favorite. Up ahead on the path in front of him were white roses, lavender roses, orange roses, and there was even a blue rose. Fred ran down the path in the sheer joy of being alive. He ran as any healthy 5-year-old might do. He ran and ran and ran. At the edge of a large green lawn, he lay down in the shade of some tall roses. He rolled his coat up in a ball to make a pillow. Listening to the robins sing, he had figured it was time for a little snooze. He tried to shut his eyes. They wouldn't shut. Hey, anybody can shut their eyes, but Fred couldn't. What was going on? He saw the roses, the birds, the lawn. He couldn't close his eyes and make them disappear. And if he couldn't shut his eyes, he couldn't fall asleep. You see, Fred was dreaming. He had read somewhere that the only thing you can't do in a dream is shut your eyes and fall asleep. So Fred knew he was dreaming, and that gave him a lot of power. He got to his feet and waved his hand at the sky. It turned purple with white-orange polka dots. He giggled. He flapped his arms and began to fly. He settled on the lawn again and made a pepperoni pizza appear. In short, he did all the things that a 5-year-old might do when they find themselves king or queen of the universe. Soon he was bored. He had done all the silly stuff and was looking around for something constructive to do, so he lined up all the roses in one long row. They stretched out in a line in both directions, going on forever. Since this was a dream, he could have an unlimited, infinite number of roses to play with. When Fred was 3 years old, he had spent some time studying physics and astronomy. He had learned that nothing in the physical universe was infinite. Everything was finite, limited. Every object could travel only at a finite speed. Even the number of atoms was finite. One book estimated that 10 to the 79th atoms in the observable, there are only 10 to the 79th atoms in the observable universe. 10 to the 79 means 10 times 10 times 10 times 10 is a total of 79 times, which is that ridiculous number right there, which is a lot of atoms. The 79 is an exponent, something we'll deal with in detail later. Now that he had all the roses magically lined up in a row, he decided to count them. Math was one of Fred's favorite activities. Now, normally when you got a bunch of stuff in a pile to count, you line them up. 1, 2, 3. But Fred couldn't do that with the roses he wanted to count. There were too many of them. He couldn't start at the left, as he did with his dolls. Dolls are easy. Roses are hard. So how do you count them? There wasn't even an obvious middle rose to start at. In some sense, every rose is the middle rose, since there's an infinite number of roses on each side of every rose. So Fred just selected a rose and called it 1. And from there it was easy to start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This set, which is a collection, group, or bunch of numbers, 1, 2, 3, 4, 5, is called the natural numbers. At least Fred figured with the natural numbers he could count half of all the roses. What to do? How could he count all the roses to the left of the 1? Then Fred remembered the movies he'd seen where rockets were ready for blast off. The guy in the tower would count the seconds to blast off. 5, 4, 3, 2, 1, 0. He could label the rows just to the left of the 1 as 0. The new set, 0, 1, 2, 3, is called the whole numbers. It's easy to remember the name since it's just the natural numbers with the whole added. The numeral 0 does look like a whole. A set doesn't just have to have numbers in it. Fred could gather the things from his dream and make a set. Roses, lawns, birds, pizza. The funny-looking things are called braces. Braces are used to enclose sets. There's a left brace and a right brace. On a computer keyboard, there are actually 3 types of grouping symbols: parentheses, braces, and brackets. In algebra, braces are used to list the number of a set, while both parentheses and brackets are used to round numbers. For example, you might write 3 plus 4 plus 9, or 35 minus 6 plus 3. Braces and brackets both begin with the letter B, and to remember which one is braces, think of braces on teeth. Those braces are all curly and twisty. In English classes, braces and brackets are not treated alike. If you want to make a remark in the middle of a sentence, as this sentence illustrates, then you use parentheses, just as I did. Brackets are used when you're quoting someone and you want to add your own remarks in the middle of their quote. 7 years ago, that's 87. But brackets and parentheses weren't going to help Fred with counting all those roses. The whole numbers only got him so far. What he needed were some new numbers. Those new numbers would be numbers that would go to the left of the 0. So years ago, someone invented negative numbers: -1, -2, -3, -4. Some notes on negative numbers. Note number 1. It would be a drag to have to write this new set as -3, -2, -1, 0, 1, 2, 3, or even worse, to write -3, -2, -1, 0, 1, 2. So we've invented an abbreviation for minus. What might we use? How about screws? The most common types look like a Phillips screwdriver, a plus, and a minus, a slotted screw. Okay, our new system will be -3, -2, -1, 0, +1, +2, +3, +4. We'll call this new set the integers. It's for real. Plus, minus. Who would have thought? Note number 2. All these integers sit on a number line. There's 0, positive numbers, negative numbers. Of course, there are more numbers on the number line than just the integers. There's pi, 3.14, a half, between 0 and 1. Half of 1 is 1/2, and decimals like 2.7. Note number 3. Positive 7 can be written either as 7 or +7. It doesn't matter which you choose. Note number 4. Phillips screws plus haven't been around forever. Phillips screws were trademarked in the early 1930s. Point number 5. When it comes to counting moose, some of these integers don't work at all. It's fine to say 2 moose. Even 0 moose makes sense. Here's a picture of 0 moose. But how in the world would you have -3 moose? You can't. Negative numbers are useful some places and not others. I guess this could be considered a mathematical proof that mooses aren't roses. Point number 6. When Mr. Fahrenheit was first fooling around with making his thermometer, he had to figure out where to mark the 0 on his thermometer. Without a 0, he couldn't have 1 degree, 2 degree, 3 degrees. He might have gone into his lab and tried to create the coldest possible temperature that would make a perfect place for a 0 on his thermometer. He might have taken his wife's fingernail polish remover, acetone, and put it into a blender with some ice. That would have been plenty cold. And all this would have been perfectly fine unless Fahrenheit had decided to take a little winter vacation in everyone's favorite winter resort spot, North Dakota. Besides being noted for famous North Dakotians such as Peggy Lee, Eric Sevareid, and Lawrence Welk, this winter playground offers the advantage of not having a lot of half-melted slushy snow to ruin your toboggan. On average, in 7 years out of every 10 in Bismarck, North Dakota, the temperature falls 62 degrees below freezing point of water. Be sure to wear a sweater. So on his scale, Mr. Fahrenheit would have to mark 30 marks on his thermometer below the 0. From -30 up to the freezing point of water, which is a +32, is his 62 degree gain. He's real. Look. Daniel Gabriel Fahrenheit. He lived from 1686 to 1736. He was a German physicist. That's pretty cool. Fred in his dream had been running up and down the line of roses, playing with the numbers as he passed. For example, going from rose marked 8 to the rose marked 13, he had to go 5 roses. That he knew from arithmetic. To go from 8 to 13 is 13 minus 8, which equals 5. Mr. Fahrenheit went from negative 30 up to positive 32. He had to go up 62 degrees. From negative 30 up to 0 is a movement upwards of 30 degrees, and from 0 to 32 is an additional movement of 32 degrees. Since going from positive 8 to positive 13 means 13 minus 8, going from negative 30 to a 32 means 32 minus a negative 30, which we know is 62. Here's some more examples. Going from 9 to 30 means 90 minus 9, which is 81. From 2 to 48, 48 minus 2 is 46. Negative 7 to 8, 8 minus a negative 7, which makes 15. The same as 8 plus 7. A negative makes a positive. Now it's your turn to play with some things covered thus far. Take out a piece of paper and write your answers for each of the following. This is important. They've done studies and have found that you learn and retain a lot more if you are actively involved in the learning process rather than just passively reading passively. So it's your turn to play. This is my set of cats. Create your own set of whatever you like and send me a picture when you send me a picture of your homework. Thanks.